All right, hello everybody. I hope you're having a great day. I would like to call upon our first speaker, Mr. Pavan Podila. Mr. Podila has been building front-end applications for close to 15 years. In this time, he has used a variety of technologies, tools, and platforms ranging from Java, .NET, WPF to iOS and Mac OS, and of course, the web platform. For the past 8 years, he has been building large-scale financial apps for big names on the Wall Street. So let's hear it from the man himself. Please put your hands together for Mr. Podila.
Thank you. Since it's a fairly small gathering, I think we're very free over here, right? Very informal discussion. How many of you have actually heard of MobX? You heard of it? Fantastic. Awesome. How many of you have heard of Redux? All of you. That's great. Right? So MobX is like a direct competitor to Redux, and today you will see why it's better, or maybe from my point of view why it's better. So I've been doing MobX development for the past 2.5 years. I'm also a contributor to the MobX project, and a book is going to be published later this year, which will be one of the first books on the market on MobX. So look out for that. That will be a very comprehensive coverage of the framework, and I'll be co-authoring this with the creator of the framework himself. So what is this thing all about? State management. Now, when you start thinking about building your UI applications, state becomes more of an important aspect of your application as you grow the application itself. And it looks something like this tornado over here with lightning striking from all over the place. And initially things look nice and simple, and you are able to manage and model your applications properly. But as things grows in complexity, like you have more async operations, you have cancellations, failures, and you have a lot of different activities happening on the screen, switching between different UI parts. All of these things become very complex to manage, and unless you have a consistent, coherent model in your head, it's hard to see it in the code itself. Now you can use frameworks like plain React, which has set state in it, or you can use frameworks like Redux, which kind of gives you a very action-oriented approach to fire off different things on the UI. Now that also gets complex over time, and you see middlewares like Redux Observable, Redux Sagas, Redux Thung, Redux Promises. The middlewares keep on bloating over time, and even Redux starts looking a little challenging and complex over time. So MobX is a different take on this particular aspect of UI development, which specifically targets on creating a reactive application without giving too much ceremony around how you create the state and how you fire off actions to mutate the state. In fact, if Redux talks about immutability of your values, this MobX is actually more about the mutable values. So it's actually a completely different take and coming from two different angles altogether over here. So when you talk about state management, there are two different planes in which your UI operates. The one is where the data lives, and the other is where the UI lives. And data is what is feeding the UI. But what ends up happening in most of our application development is that we kind of mix these two things, and it doesn't look so clean anymore. Our components start accumulating state. And over time, you start seeing that in the testing, the component becomes challenging because you have now something inherently inside it which is not obvious to you when you test it. And when you start testing it, you realize, oh my god, this component is now very complex. So it's very important to separate these two planes, where you have the state management as one aspect of your application, which is purely the data side of things, and the other is UI, where you're focusing on creating a visual representation of the data. And we'll see how MobX makes this separation very clean and simple, and also scale over time as you start building much larger applications. So we're talking about state, so let's kind of define what this state is all about, right? And this is what it looks like from a distance. And here a ship kind of sailing nicely and cleanly on the ocean. The first thing you will see is a giant mountain like this. It might look like an iceberg, right? Now this is the component state, the visual part of your application, what you see on the screen. And the component state kind of captures the visual aspects of your data, right? You have some data which you're representing as some components on the screen, and that's what it looks like to you from a distance. But what is hiding underneath is the application state. What these components are actually doing is accumulating the state and then pushing it down into the application. So as you navigate between different routes of your application or switch between different parts of your application, you are collecting inputs, maybe are showing some parts of your data, but all of them are actually coming from the application state into the component state, and the component state, through the power of controls and components, is pushing the data back into the application, which is called persistence, or using some server-side operation to kind of push it back to the actual server and so on. But these are the two levels of separation that you see in state when you talk about the client side. You have the component state, the visual aspects of your application, and the application state, which actually lives underneath, most likely not visible to you, but it's still there and kind of occupies a larger space inside your system. And to an end user, or to someone who's actually working on this application, you only always see the component state. It's an illusion actually. Your application state is the one which is actually containing all the information, the source of truth of your application itself. So I want to give you like a bunch of ideas before we move into the actual concept of MobX, and just remember all these ideas, and we'll kind of tie these things together as we talk about the framework. The next important thing in UIs is the concept of side effects. And you may have heard of this, if you're talking about functional programming languages, where side effect seems to be something that affects the outside world, and everything inside the functional system is pure. Right? You talk about pure functional languages. Now this is no different in concept. State is the pure aspect. Right? It is the central point, the pivotal epicenter of your application. Now what affects state is actions. And we already seen frameworks like Redux where they call out this concept very specifically. Right? You have an action that you fire onto the store. So state is your store, and you fire actions to mutate the store or change the store. But you also need someone to observe the store, right? Just having state and changing this is not really important or not really interesting to the end user. Someone has to observe the state and do something about it. And that's where the UI comes in. You have observers which are actually watching the state and tracking what is happening to the state and as it goes through different actions. And you ultimately represent this state onto the UI, right? So UI is what is called as a side effect. It's one of the most grandiose and glorious side effect you will have inside your application. It's also the most visible side effect. And what I call by side effects is that it is not the inherent state itself. It is a visualization of your state that is a side effect, which is happening over here, right? The state by itself is not very interesting. It's only when you try to visualize it in the form of side effects, it becomes interesting. In fact, these side effects can actually fire more actions and mutate the state even more. And as an example of this, let's say you are clicking on a button. The button fires an action. The action actually mutates some state. Maybe it makes a network call or mutates something in your state. And then all of these are actually treated as side effects because the action is, although mutating the state, it's not visible unless you see something happening on the screen. Maybe a loading indicator or the list coming up on the screen or something of that sort. So the firing of a network action, the firing of a network call when you call an action is a side effect of someone taking an action. Right? So the side effect thing is becoming actually more and more important as you think about your application, as you model your applications. So the state is at the center, actions mutated, someone is observing the state, and then these observers are the ones who cause the side effects. They show the UI, render something on the screen, make network calls, and so on and so forth. Even animations are one kind of side effect. Routing, as you switch between different routes, is a side effect. You change something in the URL, it forces an action onto your state that, okay, some page has changed. The change in page reflected as a route change on the UI. So everything is in the form of a side effect over here. And your UI is just a collection of side effects. In fact, UI itself is part of the side effect list and probably the most visible side effect that you have. So think of this as your mental model as you build your UI applications. It doesn't have to be MobX specific. Even Redux or any React application or any UI application that you build, the side effect model is the most important part of your application. And just to take as a corollary with our analogy with Redux, side effects is mostly managed in middlewares in Redux because you cannot do it in reducers because reducers are pure functions, right? So you have to do it in somewhere else in Redux, which is mostly middlewares. And those middlewares become bloated and complex over time because you're using all kinds of additional frameworks like sagas or observables to kind of manage the side effects. So with that, we are now ready to kind of talk about MobX and what is MobX and why all these things are important in the context of MobX. So someone described MobX like this, and I'll give you probably a few seconds to read about this. It's someone who has actually learned MobX for the first time. They started using it on their application, and this is a discovery they made after coming from a React or a Redux background. It's a lot of cosmic science fiction kind of words over here. But what it really means is that there are certain aspects of MobX which are very easy to follow, and you see that those concepts don't change as you grow your application. Even in the face of a growing complexity inside your application, the mental model with which you build these applications and the abstractions that you use to construct your models and the UIs almost always stay the same. They're not changing at all. And that's the power of MobX. So you learn once and kind of keep growing your application irrespective of the complexity. So let's look at some of the fundamental abstractions in MobX. Now the most important thing is the state, right? This is the center of your application. And the states in MobX are modeled as observables. An observable is not like your RxJS observable, but it's a concept of its own where it tracks the changes happening to itself. So most of the time when you're building an application, it looks like this, right? You create a graph of your models. You have something at the root where you're building up your store, and then you have store has substores and submodels and so on and so forth. So this is how you're kind of constructing the overall model of your application. And there are several ways to do this. You will managing a list of items. You could have a hash map of things, of users to some chat rooms maybe, or you could have a more complex graph of a model that you're representing on the UI. Now these are all things represented as observables in MobX. Now you can have these orange circles, which are the core observables, which is object, array, and map. And you can also have something called as a computed property, which is a derived observable that derives its value from these observables. And by defining your model in terms of the plain observables and derivations that come out of it, you can actually pretty much model everything that you see inside a UI. And we'll see a few examples of that too. A different aspect of observable, which is a more modeling around the primitives, is the observable box. We will not talk about that too much, but that's actually the underlying concept in MobX. So the next thing is the actions. Now once you have your state created, you need actions to actually mutate it. And in Redux, you have to go through this long ceremony of creating an action and then firing it on the store. The store pushes it to your reducers and middlewares. They go through this whole tree of reduction, and then they create a new state out of it, and then that goes off to your UI. Right? It's a very long and complex process. Whereas in MobX, the action is just a function call. You just call the action, which is just a function, no different than calling a JavaScript function, and it internally goes and mutates the observables simply by setting properties as a JavaScript object. It's nothing complex over here. And you don't have to worry about creating your folder structures and every feature having like 4 or 5 files. You have actions, action creators, reducers, and then you have a complexity of reducers and as the features grows in size. So all of these things don't exist in MobX. And you'll see why that's the case. So actions is how you mutate things in the observable land. And once you have actions, you need the third part, which is the reactions. And reactions are the side effects. They observe things on the observable tree, and they change something somewhere else. So this is an example where you're clicking a button. The button fires an action that says, fetch something from the network. It goes and fetches something, makes a network call, mutates the observable. Now someone is actually attaching an observer, which could be a reaction or an observer or an auto run or when. These are all APIs actually. While I'm talking about the MobX framework, I'm also giving out the APIs over here. And you see that the API is actually very simple too. So you talk about the observers over here, and the observers are the ones which are observing the change to the observables and making network calls or doing all the side effects or even rendering UI. So these are the ones which produces these side effects. And these side effects can also cause more action changes. They can actually fire more actions. As an example again is a data fetch, right? A data fetch results in a network call. When you get back the results, you again go back and modify your state, saying that, okay, this is a new list of items I have now. So if you think about MobX, these are 3 core fundamental concepts. Observables, which model the state, actions that mutate it, and reactions that listen to this change in state, and then, of course, they make other side effects on the side. UI being the most important side effect. So this is the core triad of MobX. And this is always in one direction. It's a unidirectional flow, which is kind of made popular with React as the UI framework. Things always flow in one direction. It never goes in the opposite direction. So reactions can fire actions. Actions are the one mutating the observables, and observables notify the reactions. In fact, your UI is one of the biggest reactions inside a system. It's only when the observables change, your UI can change. It's not the other way. Just because the UI is changing doesn't mean the data has to change. It should also always be driven from the data. Remember that state being on top and UI being on the bottom. The state drives the UI, and the MobX kind of makes it obvious because it's flowing in one direction. All right. So let's jump into code now, and because that's where you can start seeing all these abstract concepts in reality. So I'll start with a very simple example of a clock. And this is what the clock looks like right now in code, and this is what it looks like on the UI. A pretty static clock. But this is not really a clock, right? A clock is something supposed to be ticking all the time. It should be changing its seconds every second. So how do you go about creating a clock like this? Let's create one. So I have the React component already in place, and hopefully you guys can actually read the code. It's readable, right? So what I'm doing over here is having a simple clock component that has a render method, and I'm simply taking the new date and rendering it out by reading its hours, minutes, and seconds. That's all I'm doing. Very simple clock. And that's why you see a string with hours, minutes, and seconds separated by colons. So now we want to make this a ticking clock. So the first thing we'll do is model the data. And in our case, our model could be a const time, which could be an observable. And let's make it an object which has a value which will be our new date. All right. So obviously, we're missing a few imports over here. So observable comes from the MobX package, so let me get that. So now we have an observable. So this is modeling the time now, and the time is something that needs to be changing every second, right? But before we do that, let's actually pull this time into our clock component. So I can just say time.value, .value, because time is my constant, and that's the value. And I'm simply taking that value and showing it. No change so far. I'm still showing the time. But you want a ticking time now. So how do we do that? Set interval, right. I always make that mistake, and I always pick set timeout first and then realize it's actually set interval. So we take set interval and we pass in a function. Let's say every second we're going to take it. And then what are we going to do over here? We have to change the observable, right? We need an action. But right now our thing is so simple that we don't even really need an action for it. We can just change it directly. So I can just say time.value equal to new date. That's it. If it were a more larger application or something more serious, you would actually create an action and fire the action. Then there are some virtues and benefits to using actions, and we'll talk about that a little later. But right now we just need to modify the observables, right? So we just modified the observable, which is the time every second. Still no change, right? I mean, I refreshed, but nothing's changing on the UI. The UI needs to react to the change in the observable. It's a reaction on the change in the observable. So how do we make this connection now? How do you make the UI react to the observable? Well, it's an observer. So we just add an observer. An observer comes from the MobX React package, which is a binding library that binds React components to the observable state. And anytime the observables that you're using inside your render method, they change, the render will be called again, and then of course the UI will re-render itself. So just by adding this, we have a ticking clock. That's it. So we have an observable state. The state is changing every second, and by attaching an observer to a React component through a decorator, I have a changing state. And in fact, we can go a little further now. This may not be that interesting because, okay, you created a simple clock. But what if I want to change this clock from the outside? Let's expose this as a window.time property. So I'll make this an observable, now available on the global context, right? And I'll kind of change this every maybe 2 seconds. So I go back here. So now when I hit on time, it's window.time, right? So we have an observable object on the console, right? Can you guys see it? Right? We have an observable object. So now I can just say time.value equal to new date. No difference because I'm still modifying the date inside my observable. So let's do something different over here. So what we can do is I can add something called as a computed property, a computed observable. I can add a getter property called say is morning. Okay, and this will return it's morning if the value is say less than 12. So not value, but get hours, right? As long as you're less than the noon, you're in the morning stage. All right. The one thing I want to just quickly mention over here is that I'm using this library called Prettier. Have you guys heard of it? Right? It's a code formatting library which automatically formats your code whenever you do something to it. And it kind of has a very opinionated way of formatting the code, and kind of makes it easy to actually forget about formatting altogether and just focus on code. So here, if I do something like this and just save it, it automatically saves it and formats it. And if I forget about the spacing of things, or if I don't indent it properly, I have extra tabs and stuff in place, I don't have to worry about it. I just save it. It just works. It's an awesome tool, and I'm kind of using WebStorm over here to integrate this tool, but you can use it in Visual Studio Code, Sublime Text, wherever you want. Just set up a watcher, and it'll automatically format your code whenever you save it. All right. So we have this computed property called isMorning, and we can actually start using it over here. So one thing I can do now is I can say create a fragment. You guys know what a fragment is in React? This is a new component that was introduced to kind of skip using additional placeholder components to wrap things. Now the output of your virtual DOM should always be one root element, right? But if you put multiple elements underneath, React will complain. So we have to create this extra divs just to wrap the content. You don't need that anymore. You can just use a fragment over here, and fragment comes from the React library. So it is React fragment. All right. So now inside this, I'm going to create something called as actually, you know what? I've decided not to use a fragment. We can just change the color based on the morning or not. So I can just create a variable called text color, keep it a little simple, and if the time dot is morning, oh, bad naming. I is always capital, right? It's camel casing in JavaScript. So if time dot is morning, then I'm going to use, say, orange. And if it's night or maybe afternoon, I can just use blue maybe. All right. So and then I'll just use this color over here. So color is text color. Now anytime the time dot value changes, the computer property is also going to change. It will keep checking that, okay, the current time value, is it less than 12 or greater than 12? And as soon as it becomes more than 12, the is morning becomes true. But until then, it is false. And we are, I think, still 11:21. So, we are still in the morning stage. So I go back here, I see orange. I can do something. I can actually, since I expose the time as a window property, I can simply go to my value and assign a new date. And let's pick something in the evening. So 2018. What is today? Month is what, 4, right? And then 24th, and my hour, let's say 14. As soon as I do this, it changes. Of course, after 2 seconds, my timer is still running in the background, so it kind of changes it back. But what you're seeing over here is that I'm changed the observable, and the UI reacts to it. I didn't have to do anything special, right? This is the concept of transparent functional reactive programming, which basically means that the whole reactivity aspect of your system is transparent. You don't know it actually exists. You assume that it will actually work. You change things wherever they need to change and expect the reactions to fire off in the right times and change whatever needs to be changed and shown on the UI. So UI is the grandest reaction that you have. So I can keep changing this. Right? It's very straightforward now to actually do this kind of things. And you can build a very complex application by using these kind of modeling structures. And we'll see some of that now in the next example. So next, let's focus on a different example, which is a login form. A very classic webby kind of a way, right? This is what we grew up learning web development all about. Right? We start creating forms, we validate it, and then we keep doing it for the next 20 years, right? I'm still doing it actually, so I don't think this is going to change in the next 10 years or 20 years. So what is a login form? You basically start creating your username, password, and you hit login, and it'll fail. Well, what I've done over here is actually creating a sign-up page where you have a username and a password. So you're supposed to pick your username, which has to be only admin, by the way, and a password, which can be anything. So only when you enter the proper username, which is admin, and then hit some password, it will actually make some asynchronous calls in the background, which is why you're seeing the spinner over there. And only when both of them are correct and you have some values in them, this login will go through and not complain. Very simple one. So how do we go about modeling this stuff, right? You see a UI like this from your designer and immediately start thinking about all the controls and components that you need to fit together to kind of model this thing. But that is not how you're supposed to approach UI development. First, model the state. The state drives the UI, right? So let's model the state first. So let's go back to our form example. So how do we model the state? Don't worry about all these parts now. Let's look at the form data. What do we need and what are we capturing in the UI? We are showing a username and a password, right? And both of them are changing. And anything that changes needs to be an observable. So we mark it as an observable using this decorator. Now the reason why this decorator thing works is that it's because I'm using the Babel plugin, which transpiles the decorator to the irregular ES5 functions. And decorator is not yet a standard. It's still a would-be adopted standard. So you have to use this plugin called transform legacy decorators to kind of make use of this transform inside your code. So I have it set up in the Babel plugin, which takes care of this. So these are the two changing fields inside of my form data, and this is I'm going to spend some time kind of modeling this thing, right? So I have an observable for the username, observable for the password, and then I have something called as observable.ref. What this means is that by default, MobX is going to do a deep observation on your entire object. So if you have a very complex object, it's going to set up the observers for every single property in every single object that you have inside your graph. We don't want that. We just want to observe the instance changing over here. Right, so validation is null initially and then has some value. And I just want to observe the fact that the validation is changing its value. So I have something called as observable.ref, which only observes that value change. Then you have an observable which is saying validating, that is basically an asynchronous operation that I'm trying to do in the background. And this tells me that the validation is in progress or not. So that's the modeling of my state, right? So if you look at the UI itself, I can see that all this state is reflected in some form or the other. Username is here, password is here, and the fact that I'm in the validation phase is reflected in the spinner, right? So some state is being projected onto the UI. So once you have the state itself, we need something to keep changing the state. And who is changing the state? Well, it's the UI, right? These are the controls that we expose at the top level, and the controls will fire actions into my observable state. So if you look at the React component now, which is over here, don't worry about all this extra complexity. I'm using some material UI library over here. But essentially the thing to note over here is that the on change of the password and the username fields. These two things are actually firing off an action. So if you look at this, all it's really doing is saying form data.setField and form data.setField username password and passing in the value. This internally, the setField function is actually an action. And the way you mark actions is by calling it out with a decorator. So you have actions, observables, and then you need a reaction to react to the change in the username and password, and which is why we have set up a reaction in the constructor. So what this reaction does, it looks at a change to the observable. And what I'm looking for a change in is username and password. So anytime the username and password changes, we're going to call a validation on those fields. Now, if you don't want this behavior where you refresh, and as soon as you start typing, you see these errors. If you don't want this, well, just take off the reaction. So you don't react to the change immediately. It's only when you hit the login button will you do these tests. So it's fairly straightforward to kind of have both kind of behaviors depending on how you're creating a form. Some parts of a form could require you to validate immediately. Let's say the username, you're picking a new username, so you want like immediate validation on that. But some parts can just wait on until you hit the login button or the sign up button. This should really be called sign up, right? I should change that. Where is it? The button should be called sign up. Yeah. All right. So 3 parts of your UI modeling state, right? You have the observables, you have the actions that are fired from the UI, and then you also have an action which is submit. Now, the reason why we are using action and not simply mutating the variables is because you could be changing multiple observables inside your action. So let's say you have a complex form and you're changing, let's say, 10 fields inside of it. Now, every time you change one field, it will actually cause a reaction and cause the UI to re-render itself. Now, you don't really want that, right? You want the UI to re-render only when all 10 have been changed. So you wrap it in an action, and this action takes care of ensuring that a notification to the UI only goes out when all of the action has finished. So you can actually nest actions as well. So if I'm changing like 3-4 observables over here, I can wrap it in an action and be guaranteed that there's only one re-render on the UI happening, even though I'm mutating multiple things inside my action. So that's the reason why we are using the action decorator. And in fact, MobX kind of makes it strict if you want to by using this something called as enforce actions. So I can import the configure method from MobX and say enforce these actions. I don't want actions to change, the observables to change, anywhere outside the action. So I can import it. It comes from the MobX package. And now if I don't use an action, it will complain on the console. So let's say this one. I remove this action and go back here and change something. You'll see that it automatically complains now. Strict mode enabled. Now this is a way of guaranteeing that you are not changing things in a stray fashion anywhere in your application. If someone is actually doing it without wrapping it in action, you can actually catch that error and say, what, something somewhere is not doing it properly. Your state has to mutate only inside an action and never outside. So you can kind of enforce these things in your developer team as well. So I'm going to remove it because I always use actions. All right. Any questions so far? How about comparing with your experience with Redux? How would you go about doing something like this in Redux? Yeah.
So, like in Redux, we always have a global state, but here I'm saying that you're using this or you're using window. So, like this is how you generally store in MobX or like you also have
Yeah, so it's the same concept in Redux as well, right? You have some store somewhere, right? And we can create a store over here as well. And in fact, you can think of the form data over here as a store. And you can actually have nested observables inside. In the next example, you'll see how you can create these nested observables. So this is your store, and you can expose the form data as your top level entity, which is a top level store. And you can circulate the store throughout your application.
So and then observer is working as a store, right?
The observer? The observable itself is your store. So normally you model this with classes because you get the power of decorators. And it becomes very easy to actually see what's observable inside my store. And then actions tell you, what are the things which are going to change your observables. So this is your modeling of your state. And if you are doing it in Redux, in Redux, you would have created at least 3-4 different files by this time, right? If I were presenting Redux, then I would have been spending all my time in writing the reducer, firing of action, creating an action creator, and then calling store.dispatch at some point. Not only that, but inside my React as well, I'll have to do connect, right? And then do map state to props, map dispatch to props, create this presentation component. I'll be like doing this. And finally, I have a login form. Huh? Yeah. So any Redux flavor or any Flux flavored frameworks you take, they'll go through this entire ceremony. It's almost like your marriage can be done faster than actually writing a Redux app. All right. So let's jump on to the next example now. So now we're getting a sense of like where you're going with MobX, right? You have observables, you have actions, and reactions. That's it, just 3. Think of the triangle. Let's look at the to-do application because no session is complete without a to-do MVC kind of an example, right? But let's see how we would go about modeling this. But before we model it, let's see what this actually does in our application. So I have a to-do store over here, and you can expect all the features of a to-do application. I can currently see the ones which are not done yet. I can switch between them. Active, of course, nothing is there. Both are active right now, and none of them are completed. And the remove completed is disabled because I haven't selected anything to complete. So if I go back here and select one of this, the remove completed gets enabled. If I check all of them, complete all gets disabled because you already completed all of them, right? So if I uncheck one of them, the complete all gets enabled. And if I uncheck all of them, remove and completed becomes unchecked. There's a lot of little nuances over here. Not only that, but you can notice that the number of items are also changing, right? If I check one of them somewhere over here, you'll see that the item is also changing. Let me just zoom in a little bit. So if I remove this, 2 items are remaining. And you'll see this green thing flashing over here, right? What is that? Well, what this really tells you is that the components that are rendering right now are rather re-rendering. So anytime I change things, you'll see the components that are actually re-rendering themselves. So in this case, I only changed the item and not re-rendering the entire UI. And only changing, since you have changed the item, the count has to change. And possibly also has to change the buttons disable state, right? So it's specifically very granular and targeting just the elements that need to change based on the change in the observables. And it's very easy to do it in MobX, and we'll see in just an example how we do that. Let me keep adding some more to-dos over here. And so this is our basic application. You can add to-dos, you can complete them, you can say remove all the completed ones, the counts automatically update, and when you switch between different filters, you will see the UI automatically updating. So this is the UI. So, and this is what you need to create now. And let's see how we can model this in MobX, because modeling is the more interesting part. I mean, the UI, anybody can create this. Nobody knows how it has been done in the background, but now we'll actually uncover and see how exactly this can be done in MobX. So we have a to-do list, and you're talking about the stores earlier, right? So this is the to-do list store now. And what we have is a list of to-dos, an array, and that's an observable. And we're calling it a shallow observable because we don't want to do this deep observation. We don't want to observe the properties inside my to-do item. I've already created a separate class for that called to-do, which has its own observable properties. So this to-dos array is going to contain instances of this to-do observable, right? Description and done are the 2 changing properties of my observable. So I create a new to-do by passing in the current description, and the done flag is changed by the user. So this is my to-do list. I have my current description. The current description is what I'm typing inside the text over here. Because whenever I type things, the state needs to be captured somewhere. So that's my current description. And then what else do I have? I have a filter. And this filter is this one over here, all active and completed. So this is how I'm modeling the filter. I have all items, active items, or completed items. So that's the model so far, right? Very simple. That's it. That's the model. But we need more things, obviously. Now, how do we go about telling what should be the description that I need to show when the items keep changing, right? So here you notice that if I add these items, let me just go back to all. If I add things over here, the number of items, the count for that keeps changing, right? It tells you how many items are still remaining. So somewhere we need to actually do something to make the UI react to this change. But what we've done for that is really created a computed property. we create a property called items remaining description. And what this does, it looks at the active to-dos. And what is active to-dos? It is yet another computed property. What active to-dos does, it looks at the to-dos and filters out the one which have not been completed. Those are the active ones, right? So I have a computed property called active to-dos, and I'm building up this graph right now. You see that? I have a to-do list, I have a description which depends on active to-dos, and active to-dos depends on to-dos. And anytime I add a to-do, it will actually modify the active to-dos also, which will obviously modify the items remaining. So the state is transparently flowing into all of these computed properties, and I'm not doing anything special over here. If you were doing this in any other framework, inside your reducer you can imagine what you have to do. You'll have to make sure you modify your active to-dos, make sure you modify items remaining somewhere in your reducer, right? And these things get more and more complex as the dependencies between the state increases. Right now we have very few dependencies, to-dos depending on, active to-dos depending on to-dos, and then the description depending on the active to-dos. This is very simple, but a complex application can have multiple screens, multiple features spread across all of these different places, and these things can actually depend on each other. And when the dependency changes, you have to be sure that anything that needs this also changes. MobX kind of guarantees that with this computed property. So we have the active to-dos, and we are creating a description out of it. So we look at the active to-dos length, and if the length is 1, we just say item, otherwise use a plural for the items remaining. And that is how we get this description over here. So when I complete all, I say 0 items remaining, right? I can remove them. And when I add just 1 item, I say 1 item remaining, right? So the pluralizing and all of those things are actually taken care. Now this can actually get more complex. Imagine you're creating a localized application, right? So the store actually stores the current locale, and you can change the locale on the fly, and the description will automatically update. Because the locale changed, and the description depends on the locale, so obviously it has to change as well. So the UI becomes very reactive, and it's transparently done. You're not doing anything special to make this happen. You're just changing state, and the UI kind of reacts to automatically update things itself. So similarly, we have has active to-dos, and we're using this as a Boolean computer property. And notice what we're really doing actually. We have a very simple observable state. The state that we actually need to track is actually very simple. We just have to-dos, and description, and the filter. Everything else is built as a derivation on top of the base state. And this is how you model applications in MobX. You have the base state, and then you have a bunch of derivations to model all the different things that the UI needs. Right? If something else changes, or tomorrow if you don't need to show any of this stuff, you just remove those computer properties. So next you have this has active to-dos, which is really a Boolean property that tells you whether active to-dos has anything inside of it. And we use this to kind of turn off the enable state of the buttons. Right? So has active to-dos means that it actually has something over here. Oh, sorry, nothing has been, this has not been completed yet. So if I keep adding a few more, if I go to the active state, I can show all the active to-dos. And you can see that the remove completed is now disabled. If you look at the component for the remove completed, there is somewhere over here, just over here. So we have created a simple button, and we are passing in the has completed to-dos and the has active to-dos over here. So we're just passing it as a string, but we are referencing this property inside my action button. And this is one more important aspect of MobX. It's only when you dereference an observable inside the render method, it's when it gets tracked. So if you actually pass the value, it won't get tracked. You have to dereference the value inside your component, and only then it will know that, okay, you're actually observing this inside your render method and automatically start tracking itself. So here in this action button, all I've really done is pass the attribute, and I'm reading this attribute inside over here, which is to-do list store attribute. Since I'm dereferencing it, it will automatically get tracked. And anytime that particular attribute changes, which is has active to-dos or has completed to-dos, this button will automatically change its disabled state. Very straightforward, right? So let's look at some other parts of these things now. Filtration. How are we filtering these items over here? Well, all we're really doing is changing the filter property. That's the tracking observable, right? We're switching between all, active, or completed. And when any of them change, we have some computed properties, which is filter. So we have a computer property called visible to-dos. And all this is really doing is checking the filter, whether it's active, completed, or none, and then returning the appropriate list inside my computer property. So if it's active, I return the active to-dos. If it's completed, I return this. And if nothing has been selected, or if it's all, I return all the to-dos. So this is how we're actually kind of creating a set of derivations on top of the base state and modeling it and showing it on the UI. All right. Any questions so far? Fairly simple system, right, to kind of get started with. So you can imagine a more complex system. Let's take some examples maybe from what you guys are doing. You guys are building web apps, I assume, because that's why you're at this talk. What are the kinds of complexities you see on a daily basis? Things which are like challenging from a state management perspective, which you kind of grapple with on a daily basis, and maybe you have a lot of bugs in your Jira, tracking all the state management issues. You have something changing somewhere, UI is not updating, okay, your QA guys go and file like 10 bugs on it. Colors not changing, margins not proper, maybe components not showing up properly, and so on and so forth. A lot of different things, right? I mean, state becomes the essence of your UI. And if you model the state correctly, the UI comes as a natural side effect or an output of your state itself. So in fact, when I was creating this example, I didn't even touch the UI. For the most part, I was just living in this observable land. I was just imagining, okay, I have a mock-up coming from somewhere, right? This is how your normal day-to-day activities also probably go about, right? You get some kind of a mock-up or a requirements description from someone. You create a tiny picture of that or a wireframe of it, and then you start modeling the different aspects of the state that you need to show on the UI. So I need something to track the current text. I need to show the items remaining, some buttons, some filters, and then of course the items itself. So even though I'm adding, you can notice that the items count is changing. But since I filtered out, nothing is visible over here. I switch to active, everything shows up, and all the UI that needs to react has changed. And there is this MobX React Dev tools, which allows you to track which ones are actually changing. So you can actually click on any of these components. It tells you what is being tracked. So this little button is actually tracking a ton of things. Has active to-dos, right? Because the length property is used to create the observable, has active to-dos. And then internally it tracks the active to-dos, which internally tracks to-dos and tracks all of the done properties of all of these to-dos. So you actually can understand what is going on inside your application without having to look back at your code all the time. You can just click on things and see what state I'm trying to render over here. So here I'm just showing the filter property. Whereas if you look at the to-do item, obviously the to-do item with the done and the description. So you can see all of those things tracked inside the MobX Dev tools. And based on how you re-render things, so right now when I'm changing this text field, it only re-renders that particular part of the UI. Right? You can see this only the text field changing. Now if I dereference this text field at a higher level, then the entire UI will change. Because now the entire component gets tracked. We don't want to do that. So MobX actually recommends you to create very granular components, just targeting the observable that you're trying to observe, and then show it over there. And through this granular tracking, you never have to implement should component update. You never have to do any pure component mix-ins or pure components, or do any kind of optimization to make sure that the render happens effectively and optimizedly in an optimized fashion, right? It is, well, it's not about being fast. It's about the amount of work you have to do to make it fast. So the amount of work you would have to do in a pure component can match the performance of MobX. But imagine doing it for all the components in your UI system. It's just insane, actually. If someone's paying you to do it, go for it. But obviously, we don't have that kind of luxury. So this is the amount of work you have to do as a developer to create an efficient and effectively rendering UI. It takes very little work to actually get it done. And all you have to know is understand the observables, what is being observed, and just connect those two things, and you have a reactive UI. Yep. So you just create multiple observers of the same state.
But state, validating its state.
Mhm.
Here, if you see that it's a single page,
Right.
component itself will be taken state, right? So if I want the same state to be utilized by multiple components, just like different pages,
Mhm.
how do I approach that?
Okay, so that's about pushing more things to the store then. So imagine the iceberg diagram, component state and application state. So all these features are actually components sitting on your UI somewhere, right? But they're all deriving their state from the application state. So you model the application state with MobX. You're not modeling the component state. So what we're doing over here in this to-do list and to-dos is you're actually modeling the application state. You're saying this is the app that I'm going to build, which consists of a list of to-dos and each to-do containing a done and a description field. So this is already your application state, and it could be used by UI across your features across your UI. So you could have multiple routes all talking to the same to-do list. Now, one thing I forgot to kind of mention over here is that how are we actually injecting this store into all the components, right? So this example is fairly simple. So I'm actually creating a to-do list, and I have my component also sitting next to it. But in reality, this is not how you build your UIs. What you would be doing is actually having separate files for the stores, separate files for the state classes, and then separate files for your React components. So in those cases, what you do is use this component called provider. Just like a React connect method or a provider in Redux, you provide the state at the top level itself. So let me just go back to the application now. So let's look at this one. So let's look at the index page. So here I'm just simply rendering an application, right? But if I want to pass the store to all of my features across the entire application, I'll create a provider. And this provider comes from the MobX React package. And so let me include that. So it comes from MobX React. And this provider takes in a bunch of properties. So one of the properties could be, say, to-do list store. And this will be our to-do list store. Now I haven't really exported that, so I need to go back and do it. So let's go back here and then just export this. So now I can import this guy. So now I have a provider which is actually passing the to-do list store to my entire application. So now inside my observer, I really don't have to read it from this constant. What I can do instead is inject the to-do list store. Okay, so any component that needs the store can inject it. And inject, of course, also comes from the MobX React package. So let me include that as well. So once you do this, you will have your store ready in all the applications, also in all the components. So right now we can do the same thing over here. Now here I'm using an ES5 API, so it's not having a decorator, and things become a little more typing. So you inject it and you pass in the store that you want, so which is to-do list store. And then this creates a component, it's a higher order component. In fact, the next talk that I'm going to give is talking about all the patterns of components. So this creates a higher order component to which you pass a component which is an observer. It may look a little complex over here, but we'll break it down. So all I'm really doing is injecting the store into this component which is created by observer. Observer itself is a higher order component. Inject also is a higher order component. So I'm passing one component into the other, and inside the props, now I have access to the to-do list store. So I don't need to actually reference the global variable. It comes straight from the component itself. In fact, if I go back to my application, nothing has changed. Hopefully everything works. Yeah. Right? So this is how we spread the state across your entire application, and connecting to the store is actually pretty straightforward. You just attach an observer and then inject, and you're done. There's no connect, map, state to props, dispatch to props, and all this complexity. It almost seems like I'm kind of bashing Redux over here, but it's just a comparison, that's all. You're free to use whatever you want. All right, so let's go back to the presentation now. Any more questions, by the way? Or all good? Yes. So you can mutate the state right over here, but that's an anti-pattern, right? Because components should not do anything to the change, to the state. They should fire actions which will result in a change in the state, which makes it easy to create a more observable system, right? Tomorrow you can add more features onto your UI, which simply observes the state somewhere. And someone could be changing somewhere down below, but somewhere else in your feature you see the things changing. A classic example is localization, right? You go to your preferences screen, and somewhere over there you have a tiny control which says, okay, change my select box to point to a Chinese locale or some other locale. Now as soon as you do that, the entire UI needs to refresh, right? So how do we do that now? Well, it's pretty straightforward. You just observe the fact that you're changing the locale and let everyone react to it inside the UI. And the UI can just render itself differently. In fact, if the UI doesn't even have to do the work of creating the textual components, you could do that in the store itself. You could read up some kind of a translation dictionary and then read the string corresponding to the locale and then feed that as the item's remaining description in our case. And that's it. The UI doesn't even know that the whole thing is changing. It just works. React is a plain view, and that was the whole purpose of React, right? But what we end up doing is making the M, V, and C everything inside one component. We don't need separation of concerns, no single responsibility, nothing, right? This is the MVC triad right inside my component, yay. Of course, that's not how large-scale UIs are supposed to work. So anyway, so you can see the power of MobX. Of course, this is not enough to make you, fully expert into the MobX philosophy. You should start using it, and you'll see that things become very simple. I would suggest trying out this application itself, when you have some free time, and compare it with Redux or any other state management framework that you have used in the past. If you come from Angular, maybe you used NGRX platform, NGRX store, RxJS observables, or you come from Backbone using plain JavaScript observation, so on and so forth. Or Knockout maybe, which nobody uses anymore, right? No Knockout users over here. It's a dead state management platform. Anyway, so if you look at any of these inventions that were done in the past, MobX kind of improves upon it. It borrows a lot of things from that and makes it even better in terms of developer experience. All right. Let's go back to the slides. So this is what you need to remember in this talk. You have three concepts in MobX: observables, actions, reactions. And this is a triad, and things always flow in one direction. And make sure you're showing this direction in clockwise fashion, right? Not anti-clockwise. You could do anti-clockwise too, but then you have to replace the triangle elements. So you always flow in one direction. Reactions fire actions. Actions mutate the observables. Observables notify the reactions, and then that's how the whole system works. And because of this, there is no confusion as to who is doing what. The responsibilities are very simple and cleared out. State management is its own plane of operation. UI is its own plane of operation. And there is some connection happening between through a glue we create through the MobX React package. Right? So there is no mixing of things. So there's a few more things that you can do in MobX. Of course, I just talked about MobX and MobX React. There's also MobX React Dev Tools that gives you the experience of checking which components are rendering. And you can actually improve performance by making sure that you're only targeting just the observables you need to change that render of the component. If you target too many observables, then you're rendering too much and maybe reacting too much. So you just try to make sure, create components which are very granular and just attack the part of the observable that you need. You have MobX utils for kind of more complex async-based operations where you're tracking these varieties of async operations. You can actually do that very simply with MobX utils. And then you have MobX state tree, which is a more complex project. Not complex in the sense that it's difficult to use, but rather bakes in a lot of the opinions that people have built by using MobX over the several years and creates a framework where everything is kind of given to you in a very prescriptive fashion. So you know how to create your observables, their actions, the views, and there is a thing called snapshots where you can actually create snapshots of a state and create this time traveling experience that you get with Redux. So all of that is actually built into MobX state tree. And that's it. That's MobX. Any questions, comments? All right, all look astonished, so obviously something has gone into your heads. All right, thank you all. All right, now it's time to run.